Okay, good morning. Welcome to
FunMath72.
Fun Math number 72. Back to clocks, because we're the review part of our little chapter on angles, and it might be fun to revisit clocks, especially when maybe the lessons didn't sink in all the way. But I think we'll get through this pretty fast. What is the smaller angle made by the hands of a clock at 3:15? Okay, how do you want to approach this problem?
Draw a clock.
Actually, let's draw the clock a little bit more out of the way. But you're right, let's draw a clock. Sorry. Let's draw the clock over here so that we have a little bit more room to write. Okay? So 12, 6, 3, 9. Okay. So what angle are we looking for?
We're looking for, here's the out hand. It's not pointing exactly at the 3.
Right, it's not pointing exactly at the 3.
But the minute hand is.
The minute hand is pointing exactly at the 3. So we're looking for that angle there. Okay, so how are we going to find that?
Well, an easy angle to calculate is an angle at 3 o'clock.
Okay. Alright, so this is a hard angle to calculate, but luckily 3 o'clock is actually an easy angle to calculate. And what angle is that?
It's 90 degrees.
90 degrees. Okay, so why don't you write that down? At 3 o'clock the angle is 90. Okay, awesome. And what do we know next about a clock?
Well, we know that the minute hand moves 360 degrees in 60 minutes.
Okay, the minute hand moves 360 degrees in 60 minutes.
And this is 6 degrees per minute.
Yeah, 6 degrees per minute. Okay, awesome. So what does that mean? How is that going to help us?
Well, the minute hand is shrinking the angle.
Okay, the minute hand's shrinking the angle, and it's shrinking it at 6 degrees per minute.
The hour hand, well, it moves 30 degrees in 60 minutes.
Okay, why is that?
Because this is 30 degrees.
Okay, each one of the wedges on our clock is 30 degrees, and how do we know that?
Because there's 12 of them, and there's 360 degrees in the clock.
Okay, awesome. So the hour hand moves 30 degrees in an hour.
Or half a degree per minute.
Or half a degree per minute. Okay.
This is what we know. And the hour hand's expanding the angle.
Okay, so let's draw a picture of what we mean by that. At 3 o'clock, we have an angle like this. As time moves on, remember time's not frozen, right?
Yeah.
Okay, as time moves on, the minute hand, is moving towards the hour hand. And it's making the angle smaller. So the minute hand's saying, "Come here, hour hand, I'm going to get you. You come back here right this side." And the hour hand is moving away much more slowly. So the hour hand's going, "Oh, I can't run away from it." Right?
Yeah.
Okay, so the minute hand shrinks the angle, and the hour hand is increasing the angle. Okay, so that's good. And we know this angle initially starts off at 90. So what are we going to do next?
Well, we can make an equation.
Okay, what's your equation going to say?
Well,
unfortunately, let's erase. It's unfortunate to erase because our board's getting very hard to erase. Okay, what's your equation going to be?
We're going to have 15 minutes, because this is 3 o'clock, and we're looking for 3:15.
Okay. Well, what's your equation going to say?
Well, it initially starts off at 90.
Okay.
So
what are you trying to describe with your equation?
we're trying to describe how the minute hand moves closer and the hour hand moves away.
Okay, very good. So we're trying to describe this angle as a function of time. What does it start out as?
90.
That angle equals.
Right now it's 90.
Are you holding anything in your hand? Okay, so it's 90. And what does the minute hand do to the angle?
shrinks it.
Okay, by how much?
6 degrees a minute.
Okay, so 90
minus 6t.
minus 6t.
Plus 1/2 t, because the hour hand's moving away.
Okay, so here's how we construct our equation. It tells us what the angle is at time t. It's after 3 o'clock. It starts out at 90. It shrinks at 6 degrees a minute. So that's where we get the minus 6t. And then it increases at 1/2 degree per minute. Okay, and what time are we looking for the angle?
3:15.
Okay, so how many minutes have passed since 3 o'clock? Okay, so why don't we put 15 minutes into our equation and see what happens? The angle is
90 minus 15. Minus 6 times 15.
That 6 is important. Minus 6 times 15.
Which is 60, it's 80. No, it's 90.
90 minus 90 plus...
Plus half of 15 is 7.5.
Okay.
Well, the angle, these 90s go away, and the angle is 7.5.
The angle is 7.5 degrees. Which is a pretty small angle, right?
Yeah.
But remember when we drew the picture initially, we said the hour hand's going to have moved away a little bit, and the minute hand's going to have moved right there.
So it is small.
It is small. Okay, so that is really nice. Now, the other way we could have solved this problem, this is a very sophisticated way to solve the problem, which is good. That's what I want you to learn. The other way we could have looked at this and we could have said, well, the minute hand is exactly on top of where the hour hand used to be at 3 o'clock, right?
Yeah.
Okay, so all we have to figure out is how far did the hour hand move? See, we had a 90 minus 90 here. That's why. That's what that's saying. That minute hand's exactly on top of where the hour hand used to be. Okay. Well, what percent of an hour has passed in 15 minutes?
It's 1/4 of an hour.
1/4 of an hour. How much does the hour hand move in an hour?
It moves 30 degrees.
30 degrees. So we have to do 30 degrees divided by 4. And what is 30 divided by 4?
It's 15 over 2, which
is 15 over 2, which is 7.5. That's the other way we could have looked at it. Okay? This way seems easy for this very specific angle.
Yeah, but angles are like...
But this way is a much more sophisticated way to solve for any time.
So this is hard for angles like 9:22.
And 30 seconds or something like that. Yeah. Yeah.
And
all right, so we'll keep reviewing this week. This will be a week of clocks. A week of clocks. Sounds fun.